Hey guys, so my name is Aman Pradhan, and I'm a deep learning and computer vision engineer at a company called PlayShifu, and hopefully soon to be a Udacity mentor as well. So, the topic that I'm going to discuss right now is called GAN, or Generative Adversarial Network. What are GANs exactly? So, GANs is a kind of architecture proposed by Ian Goodfellow in the year 2014. So, what does GAN do? Well, as the name suggests, it generates things, right? GAN is divided into two parts. Okay, the generative part, which is done by something called a generator, okay, and adversarial part, which is something done by an architecture or a part of it called the discriminator. How do I understand what GANs are, right? So there is this great analogy which has helped me a lot to learn what they do and how they do it, and I hope they do the same for you as well. So what do we have here is, suppose there is a thief, okay, or a money counterfeiter who wants to generate fake currency. Cool. Now there is a police, okay, which identifies which currency is fake and which is not. Cool. Get this analogy, we'll work on this later. Now, what happens is, our generator, okay, alright, or the thief or the fake money counterfeiter or someone, that person generates fake currency, okay. But the problem is, that person has never generated fake currency in his life. Now what happens is, the police has also never checked which currency is fake and which is not. But it has some knowledge about which is which. Now the work of generator or a thief is to basically generate fake currency. The work of the discriminator or the police is to identify which currency is fake and which is not. So the entire architecture of it goes like, our thief is generating fake currency. Cool. It gets passed on. The fake currency is passed on to a network. And there is a real currency. Okay, it is getting passed on to the network as well. Now the work of the discriminator is to assign labels as to which currency is fake currency and which currency is the real currency. Initially, our generator doesn't know anything about fake currency, so it generated something. Okay, it generated anything. Now it goes to the discriminator, and at the start of it, discriminator goes like, okay, I know this is a fake currency and this is the real currency. Easy task for me. And okay, now this error gets back propagated to the generator. Now if you don't understand what back propagation is, well, back propagation is something like, you learn from your own mistakes. Okay, you make mistakes, you understand what wrong you did, and then you rework on it, and you keep on doing it, you keep on doing it until you get something meaningful. Okay, now what happens is, the first time when generator discarded when the discriminator discarded the output made by the generator, now generator gets a bit smarter. Okay, it understands, okay, I can do this better and I'll be able to, fool the discriminator around. Now, with the previous epoch, as the generator got smarter, sadly the discriminator got smarter as well. Now it has a better idea, okay, this is real currency, this is fake currency. And this cycle keeps on happening. This cycle is so rigorous and it keeps on happening so many times that there comes a point during the training when generator is able to produce almost the same currency as the real one. Okay, and the discriminator can now no longer distinguish, okay, this is the real one, this is the fake one. Now, interesting, right? Now, there are some things associated with GANs as well. First thing that I'd really like to suggest is that training GANs is hard. It takes time, it takes a lot of, it takes a lot of effort to train a GAN model. Because the thing is, okay, I may be going into some, deep information, but the problem that I believe right now in the GAN structure is, we still do not have a good loss function for that. Okay, and but I guess, okay, let's not go there. Let's just understand that it is, at this point of time, it is very hard to train GAN models. Well, when I was doing my Udacity Nano degree, there was this one project where I had to generate faces. The project was called face generation. Okay, so what I did was I had a dataset called syllabi dataset. I made my generator, I made my discriminator, and with time I can see that generator was generating just pixels, and then it kept on improving, kept on improving, and kept on improving until there comes a time when my generator, the generator that I designed, was able to produce real human like images. Okay, so that was without a doubt one of the most interesting projects that I have ever done, and I sincerely hope that if any of you guys are trying to do that, you'll have fun. I mean, that I can guarantee that you'll have fun doing that. Okay, now what can we do to make sure our generator make sure our GAN give better results? Ideally, we can start pre-train our discriminator, because if the gradients of the generator and the discriminator are a little bit different, then it is seen that the training gets easier and maybe even quickly as well. So the word that I'm going to leave you with that is GANs are awesome. GAN are groundbreaking. GANs have changed the game, and they're used in a lot of fields like robotic simulation. That is a very big field for GANs, and GANs are used for generating images, generating fake data, and it is seen that our neural network are responding to it. They're performing very well on that data, and well, it is something that you can try. Without a doubt, you'll have fun. At the worst of it, even at the worst of it, you guys will have fun. Okay, so I believe that you guys understand that what GANs are, how do they work. Okay, I hope that it was interesting, and I hope you guys like the video. Thank you.